Welcome to Where Next Happens, live from Discovery X. It's incredible to be here at Ontario's biggest innovation event, surrounded by the brightest minds in tech, research, and entrepreneurship. There's so much energy in this room. It's clear that big ideas are being shared, partnerships are being formed, and the future is being shaped right here. I'm Dr. Claudia Krywiak, President and CEO of the Ontario Centre of Innovation and the host of this brand new podcast. We'll be talking to the innovators and experts pushing boundaries, solving big challenges, and exploring where next happens. So stay tuned. And in today's conversation, we're talking about one of the most exciting frontiers in innovation, quantum computing. It sounds like science fiction, but it's happening now, and the possibilities are huge. We're talking about technology that could revolutionize industries, everything from materials science to drug discovery to climate modeling. But there's still a long road ahead before quantum computing is fully realized. So what's next? And who's leading the charge? Canada is already a global leader in quantum technology. The government has invested heavily to help commercialize quantum research, and we're home to 5% of the world's quantum talent, even though we only make up 0.5% of the global population. Quantum computers work in a completely different way than classical computers, leveraging the strange and powerful principles of quantum mechanics. And one of the companies pioneering this revolution is based right here in Ontario. Xanadu is pushing the boundaries of what's possible in quantum computing. Founded in Canada, the company has been making global headlines with breakthroughs in photonic quantum technology. Christian Weedbrook, the founder and CEO of Xanadu, joins me today to talk about building a quantum startup, competing with tech giants, and where this industry is heading next. So, Christian, what sparked the idea for Xanadu, and why did you choose to build Xanadu here in Canada?
That's a good question. Actually goes back to my personal history. So I did a PhD in Australia in quantum computing. And then after that was a postdoc at MIT. And then came to Toronto after that as a postdoc. In terms of starting Xanadu, it was really about trying to commercialize the research community in photonic quantum computing that I was a part of. And before that, when I was a teenager, I always loved, and still do, reading about entrepreneurs and businesses and things like that. So it was really both of them converged together. And after I finished my postdoc position, I thought it'd be great to sort of try and see if I can commercialize the field that I was a part of for many years. And also, I love Toronto. So I arrived here for my postdoc in 2010. So it's already been 15 years. And have been here ever since. And it just felt like the right city for me personally and also professionally. So all the factors came together.
Why the name Xanadu?
That's after Olivia Newton-John song.
Oh.
Yeah, and the songs from the movie called Xanadu. I always liked the movie itself, personally, is not that great, I thought. But we've also raised more money than what the movie made at the box office. So that's always fun to think about. But the other thing too, Olivia Newton-John sang this song, which we're named after, but her great-grandfather, or her grandfather, I should say, was Max Born, one of the most famous physicists of the 20th century. So it has another connection as well.
Interesting. So Xanadu's been doing quite well recently. And back in January, you made headlines worldwide with the introduction of Aurora, which is the world's first scalable network and modular quantum computer. So can you tell us why that's a big deal? Why is that such a huge breakthrough and why it attracted attention from around the world?
Yeah, I guess the best place to start is looking at our vision. So our vision is to build a quantum computer that's much bigger than what us or anyone else has today. And the vision is actually a quantum data center. So you'll have an acre or two of land that's inside the data center will have thousands of quantum server racks that are networked together. That's the vision. Our first one will be in Toronto. That's also the goal. Now, when you start there, you look at what you need to do to achieve this quantum data center. You need networking. So very much like traditional data centers, you'll have thousands of server racks. Inside each server rack are smaller computers, say CPUs or GPUs, but they talk to each other using light or photons. They're interconnected, they're networks. That's been done for a while now. That's a solved problem in traditional data centers. But to do it quantum mechanically, so if you take the smallest instance, networking two quantum computers together, no one's done that before in a scalable or modular way before. So in order to achieve our mission, we had to have shown how to do that. And that's why it was a big deal. In fact, we have a very small quantum computer called Aurora that you mentioned, and it's 4 server racks. So a really baby data center. Ultimately, we want thousands of server racks networked together. So no one has ever done that before in the quantum community because it's very, very difficult to actually network quantum systems together, ultimately because you're dealing with quantum mechanics, quantum physics. So putting all that together, we're one step closer now to our vision of a quantum data center. And it's very hard to network on computers.
So how does this advancement fit into the broader landscape of recent quantum advancements that have been announced by some of the big companies like AWS's Ocelot chip, Google's Willow chip? Like, can you kind of give us a bit of a perspective what this means for the sector overall?
Yeah, very, very much complementary achievements. So us and others will have to build a large-scale quantum computer, a quantum data center. The two big challenges at the moment is the networking side of things and error correction. So you'll often see achievements in the next few years related to those two big hardware buckets. So they both are needed for the quantum data center, and that's everyone's goal. The quantum networking side of things was our announcement. And to your question, Google's and others, they've done great work in the error correction side of things. So it's very much complementary. And, all these results are really pushing the field further, towards the vision. And it really is at this point in time, a kind of rising tide lifts all boats sort of, feeling with all these great achievements.
So these advancements are quite notable, and it seems like the path to practical quantum computers, or the timeline to practical quantum computers, is accelerating and condensing. But at CES earlier this year, NVIDIA's CEO said that we're still 15 to 30 years away from practical quantum computers. Do you agree with that timeline, or are we much closer to real-world quantum computing than most people seem to think?
Well, from our side of things, when it's really practical is when you have this data center. Another way to look at it is a quantum data center, once it's that big, can now start solving important problems in chemistry, drug discovery, material design, AI, and so forth. So that's kind of where we're headed. Our goal is to build that data center here in Toronto in 2029. So that's, under 5 years away. The CEO of NVIDIA also backtracked on his comments a couple of weeks ago at the NVIDIA conference. And he said that, he didn't really know as much as what he does now. And he's talked to more people, and it's much closer. And NVIDIA also is investing quite a bit in quantum computing, not in the hardware side of things, but in things related to the GPU development of quantum computers.
So we are much closer than most people think. Let's talk a little bit about Xanadu, and as a scale-up and a startup going head-to-head with giants like Google and AWS. How does any startup stay competitive and continue to innovate in such a fast-moving industry, especially when the competitors may have much larger resources and funding and talent at their disposal?
Yeah, one thing that comes to mind is focus is very key. So us and other pure play quantum computing companies, meaning that's the only thing we focus on. It's a huge advantage when you're going against Google. They're not a pure play quantum computing company. They focus on many, many different things and many different projects and do wonderful things in a variety of different fields. So I think focus is key. From our perspective, we're using light or photons to build our quantum computer. We're obviously very big believers in this approach, and Google and IBM and Microsoft are not using a light-based approach or a photonic-based approach. So we can compete in a very different way of building our quantum computers. Now, we all have pros and cons, in terms of our approaches that we've chosen. But, the scalability side of things that we talked about before with our quantum computer Aurora, it really gives us a leg up. When you look under the hood also, these companies, like you said, they have, in some sense, near infinite money, resources. But, I believe our team is actually, our team is at 230, which I believe is comparable or more than what Google has. And also, every team in Google is competing for funding and resources internally within Google. So it's not just an easy thing. They're competing with DeepMind, they're competing with Waymo, they're competing with many other different factions within Google. So, the reality is a little bit different. But so I would say, also the fact that we have a photonic-based approach, and it's just sometimes it's hard for them to raise money than what it is for us externally.
Can you talk a little bit about the competition for talent? That's one of the things we hear quite often from startups that are in areas where very highly skilled talent is required, either in computer science and physics, in your case in quantum computing, where that talent pool, the competition for that talent is global. The talent pool is very, very narrow. Can you talk about some of the strategies startups can use to compete for that type of talent when competing against the likes of the big tech behemoths?
Well, I think you have to do something unique. If you're going against, say, Amazon in terms of AWS, it's going to be very hard to compete. They started, I think they themselves also had a 4-year head start compared to Google, IBM in terms of data centers. But for us, using a different architecture, the photonics that I mentioned, gives us a uniqueness. So always ask yourself, what's your uniqueness in a company and also in life? How do you get that edge that no one else has? And using photonics is good. I think being in Canada is a huge edge for us as well. And then, in the early days, we started in 2016. The first, I think maybe 80 hires were all PhDs. So starting back then, no one was really doing our approach. And so, again, the uniqueness came out, and we were able to hire a lot of people that I work with, or people I worked with, people they knew. So that was really key. Now, what we're seeing in terms of the workforce, first off, there's more and more quantum companies, so it's inherently more people that are getting trained or getting into it that you can kind of work with, or, they'll move between companies. So that's good. The other good thing is that we're not hiring, really PhDs anymore. We're hiring chip designers as one example. And these chip designers work at Intel, NVIDIA, and so forth. So it's a double-edged sword. The good thing is that now it's less esoteric. It's not, quantum physicists, experimentalists in quantum optics that we're hiring. Mm-hmm. It's now people that have are more commonly available. Now, the downside is you're trying to, take them away from well-paid jobs at large companies. But I think that's where a startup also offers. You're offering something that's getting it on the ground floor. You're not at a company that has thousands of people, tens of thousands maybe. And so you offer something very different. So it always comes back to that uniqueness and what are you offering someone? Also, what we offer in quantum computing is something that in principle could change the world. So that's very exciting as well. So always look for your uniqueness and how you can get that edge that maybe not everyone else is looking at or doing at the moment.
So one of the unique factors that you mentioned as being advantages is being in Canada. And that's interesting to hear you say that, because often we hear startups and scale-ups talk about the challenges of being in Canada in terms of commercialization. The market is much smaller in Canada than it is south of the border. Access to capital is more limited. In the past, you've always spoken about growing and starting Xanadu in Canada and being committed to it because you see that as an advantage. Can you talk a little bit about that? And as Xanadu continues to be successful and continues to scale, do you think it will be harder for you to keep Xanadu in Canada and Canadian?
It definitely is a challenge, if I'm being honest, because you're always getting a kind of a pull towards the US. But again, coming back to this idea of an advantage or an edge, there's like a few companies that are doing quantum computing like us in Canada, but there's probably 10 times the amount in the US. So you can't really stand up above everyone else if there's so many people. It's much harder. I would say in terms of the product, we have to be global. So our ultimate goal is to build quantum data centers all around the world and start off in Canada and so forth. So we won't restrict ourselves to Canada in terms of the market. That wouldn't make sense. But, in terms of the funding, there is a lot of funding in Canada. It's just a case of showing the investors here that the opportunities are also here as well. You hear about so many talented Canadians that have moved to the US historically. Well, they could have stayed in Canada. The money is there. As entrepreneurs, we just got to show that if we're willing to stay, the money can, be accessed as well. So it's a chicken and the egg. The entrepreneurs have to do their job, but also the investors as well. And, in terms of the government, we managed to get $40 million strategic innovation fund from the Canadian government. That's huge. And it's because there's less players in Canada. You can kind of get a whole country rallying behind you, talking to the politicians and the business leaders and so forth. So, I would say it's just an opportunity about finding your uniqueness. I always look at places like Singapore, Taiwan, Korea. They're not as large as the US, but they're also competing and doing some wonderful things. Samsung and many other big tech companies as well. So I think when you see, the old thing is when you see challenges, think of it as an opportunity and how you can kind of change the way you look at it. And that's what we've been doing.
So let's talk a little bit about what policymakers and governments can do. So Canada is recognized as being a global center of research and talent excellence in quantum computing. Companies like Xanadu, the startups coming out of CDL's quantum cohort show a lot of promise. What do policymakers, what do governments need to do to ensure that we don't just excel on the research side, but we actually capitalize on the commercial opportunities that will be created in the quantum computing space? And how can we ensure that Canada becomes a global hub for the development and commercialization of quantum computing related technologies?
Well, there's probably a few answers to that. I can only speak on what would help us and kind of extrapolate from there. The first thing I think is funding. I'm speaking about quantum and deep tech. Having funding is the best way to do it. Because you don't want the talent, their first thought is there's not funding here, there's not opportunity, I have to go to the US. And funding changes all of that. So I'll give you a specific example is, we're raising money at the moment. BDC has been a great supporter in the past for a relatively small check size. Now we've gone beyond that. And there's no, BDC wants to do it, but there's no kind of avenue for them to invest in someone like Xanadu, where deep tech and quantum computing typically doesn't fit the revenue milestones or metrics that they need. But there's a lot of money in BDC. It's like, they would like to work with us. We'd love to work with them as well. So there could be, wherever there is currently funding, like BDC, there could be policy changes there. But I think that one of the best things that could be amazing is, I spend a lot of time talking to sovereign wealth funds around the world. Create a deep tech fund in Canada and put, say, $1 billion in it. And let everyone know that it's there, so other people can keep accessing it and starting their own companies. So to me, it's very clear that funding is the easy answer there. It's obviously difficult to do, but there shouldn't be barriers to that sort of thing, unless we want to keep losing all our talent to the US.
So let's pick up on the commercialization piece. Where do you see some of the earliest real-world applications of quantum computing, specifically when we think about Ontario and Canada, and how can we capitalize on those early wins?
Well, the math and the latest research tells us that the smallest quantum computer in terms of, say, the amount of qubits is about 1 million qubits that you can start successfully solving important customer problems. So given that, the research and our research and others in the community suggests that quantum chemistry is the lowest hanging fruit. And for us, we're focused on next generation battery development. So once you have this quantum data center, how do customers access it online and use it to develop new materials and candidates for batteries, which is going to be a very big thing. So that's kind of where we're restricted at the moment. Bigger quantum computers, bigger data centers will be able to access other things like AI, quantum and AI, finance, and drug discovery. They're the ones that are initially everyone's after. But a lot of the stuff, say we're working specifically on next generation battery development, a lot of the tools and that are used for that analysis can be ported over to many other things within the broader field of quantum chemistry. So in Ontario, wherever there's things like batteries, which we know there's battery plants and things like that, or quantum chemistry, new materials, that's where a quantum computer can really help Ontario excel.
It seems like we might be at a tipping point. So in Ontario, we have the research expertise, we have the talent, and we have significant investments in some of the sectors where the early application areas of quantum computing might be realized. So EV, electric vehicles. Speaking to your point about the role of quantum computing in battery technology development, the financial services sector. So we are one of the global financial centers of excellence globally. And then drug discovery. So life sciences sector is key as well. So it seems like it could be the perfect storm. But going back to your earlier comment, investment and funding is 100%. Going to be the key, especially since, and I would also say patient capital is going to be the key, because the revenue model's a little bit different in this sector than in some of the other sectors.
Yeah, and it's interesting is the revenue model is different. Basically, different means there's little revenue at the moment. But like you said, when you have long-term patient capital, you now start seeing things differently where you can tolerate little to no revenue. Because typically when you have companies like that, like quantum, it's proportional to transformational things in society. If you've got revenue, large amounts of revenue now, most likely you're probably just a normal business, a usual business. It's the technology is there, it's been vetted, people know how to use it. But for things that are really just transformational, you don't really know what to expect. Think of the internet in the early days. People were asking, what is the internet in the early 90s? When the first integrated chips came out, say Intel was started in, I believe, 1968. They couldn't have foresaw all the stuff to do with the internet today, the advent of mobile computing, AI where it is now. So you need people to take these big bets, and they need to be in the form of large amounts of capital. And also, let's think big. Let's think, if we can keep the Canadian entrepreneurs here, how do we attract the best from the US? Mm-hmm. There's no reason why we can't do that as well. So I think there's a huge opportunity. I think also with the tariffs and a lot of the pushback that Canada's getting from the US, I think it's a great time now to be thinking about our sovereign technology, sovereign wealth funds, onshoring of materials. It's just there's a lot of downside to what's happening at the moment. But again, how do you flip it and think about what opportunities do these things bring? And I think it's enormous.
But let me ask you, Christian, so scaling quantum technology isn't easy. What lessons have you learned?
Well, I'd like to, in terms of that question, take out the quantum side of things. And I think when you're doing something very hard, like starting a company, nothing beats a huge amount of sacrifice, an extreme amount of hard work, things that, I haven't mentioned quantum at all. And having a purpose. And why do we get up every day? What is it that excites us about life? These are the big things that I think are important for our life. And how can it bleed into our workday? I think that's so important, because that's why I get up, but it's very, very challenging at the same time. You have to persevere. Anything in life worth having is really worth working for and sacrificing, whatever it is. It doesn't have to be a business. It could be anything. So all of the things I've learned or continue to reiterate in my own mind, I just have nothing to do with quantum, but they're applicable to anything when you're trying to do something important. And that's really meaningful for yourself as well.
I remember you and I had done a fireside chat previously, and we were in a green room. And I think I asked you a question along the lines of, well, how's it going? And you said that one of the things you didn't realize is how completely consuming it would become, especially as you start to scale up and truly scale up a company. So what are some strategies for kind of dealing with kind of working and functioning at that level, whereas you're scaling a company, it completely consumes every aspect of what you're doing?
Well, I think you have to love what you do, and it has to be meaningful for you personally. I think I mentioned also on that stage, take something that's popular at the moment. And I think the example I used was, let's assume someone told me I could, sell sneakers. I would be a billionaire after 10 years. I wouldn't take that, because I wouldn't do a business based on sneakers, because I don't care about sneakers. It doesn't drive me personally. For someone else, it may. You can't get up every day for 10 years, work every single day of the year, and still make it through, basically. So you have to have that purpose, really understand why you're doing it, and know that it's going to take a huge amount of sacrifice as well. But I think it comes back to the idea of purpose and not doing something for money per se. I think if you get other things right, the money will come. And so, yeah, that would be my advice.
So the question I'd like to end off with is, where next? So what's the moonshot for Xanadu and more broadly for quantum computing over the next decade? So how are the next 3 to 5 years going to foster or facilitate that moonshot for Xanadu and for the sector?
Well, it's an easy thing to say. It's building this quantum data center. So our vision is very clear. Have that done by 2029. Easy to say. It's going to be very hard to do. By looking at our team's past track record of hardware achievements, I think we'll hit it. But it's very clear that that's what we're living and breathing at the moment. And you think of the data center, but it gets broken down to all the key parts that all the many teams that are working on. So they're all coming together to build this data center. And it's at that point a quantum computer is large enough that you'll start seeing some important transformations in business and science, and hopefully in a positive way, humanity as well.
And so let's fast forward to 2029. You've achieved your moonshot. You have the quantum data center. What does that mean for quantum computing?
I think finally quantum computing is truly here. So quantum computing is here today. We have quantum computers and so do others. But you're not seeing the full impact of it yet. And by 2029, with the quantum data center, you'll truly start seeing the initial first impact of quantum computing. Much like, say, the mid to late 90s, you saw how the internet was slowly taking off. I think it'll be the dawn of a new era of computing, and we'll start, starting to really, we'll be discovering things, hopefully, and then also into early next decade, things that we didn't know of because we didn't have access to these computers to discover new things as well. So if we get there, it's going to be a very exciting time.
We hope that, and we know that you will achieve the moonshot, because it will be a tremendous accomplishment, not only for Xanadu, but imagine the world's first quantum data center in Canada. And that will be a moment in the history of civilization as a critical point where quantum computing is here. So we wish you all of the best in that endeavor and anything that we can do to support you. And OCI has been... it's been our pleasure and privilege to support you right from your early days when you were coming out of U of T and saying, I want to be an entrepreneur and I want to do commercialization. And we're like, yes. And then you said quantum computing and we're like, we're very grateful that you persevered, and congratulations on all of the amazing work that you've done.
Thank you.
Thank you so much for joining us today, live from Discovery X. And thank you, Christian, for sharing your insights on the future of quantum computing and the incredible work happening at Xanadu. To learn more about what's next for Xanadu and the quantum industry, visit xanadu.ai. If you're as excited about the future of innovations like quantum as we are, make sure to stay tuned for more episodes of Where Next Happens. We've got a lot of exciting conversations ahead, and we can't wait to share them with you. Thanks again for being here. Let's keep pushing the boundaries of what's possible together.